Okay, in this video, we're going to talk about Unit 9, Objective 4, separation of variables. And separation of variables are going to be used to solve differential equations. Differential equations, I mentioned in a previous video, it's just an equation that has a derivative in it. So if we see something like this, that's going to be an example of a differential equation. dy dx equals y times x sine x squared. So we've seen these when we were going to make slope fields, so we would make slope fields based on differential equations. Now what we're going to do is we're going to actually solve that differential equation. We're going to come up with what function actually has that derivative of yx sine of x squared. Now sometimes they'll give you just this and they want the general equation. So we'll have like a plus c that we can move up and down. And other times we'll have to find the particular solution, and in which case they'll give us some point on the graph. So in this case we're going to say 0, 1. So we want to solve this differential equation, y times x sine x squared, that goes through the point 0, 1. Now there is a set algorithm, a set bunch of steps that we need to take in order to solve our differential equations using separation of variables. So I'm going to put those off to the side as we work this one out. So the first thing that we're going to want to do is we're going to want to separate all of our variables. We're going to want to get all of the y's on the left side, all of our x's on the right side, and that includes our dy and our dx. So we're going to divide by y to move it to the left-hand side, and we're going to multiply by dx to move it to the right-hand side. And we're going to get 1 over y dy equals x sine of x squared dx. So that first step, we're just going to say separate variables. Hence, separation of variables. So we want the x's on one side, we want the y's on the other. Generally speaking, we're going to want the y's on the left because we want to multiply that dx to the other side. So we have these things, 1 over y dy equals x sine x squared dx. And what we want to do now, if we're going to try to get y, I need to get rid of the dy and the dx, so we're going to anti-differentiate each side. So we're going to take the antiderivative of 1 over y dy, the antiderivative of x sine of x squared dx. So we'll say step 2 is going to be anti-differentiate. So antiderivative of 1 over y dy is going to be the natural log of the absolute value of y plus c, and we're going to call that c1 because we're going to get a c on the other side, and those two c's don't have to be the same thing. Antiderivative of x sine x squared, we're going to need to use u substitution. U is going to be equal to, oops, let's not do it that way. It's hard to see. Let's go with this color. U is going to be equal to x squared, so du is going to be equal to 2x dx. So we can't have that 2x dx because we just have the x dx in our integrand. So divide by the 2, we're going to have a 1/2 out front. So really we're going to be looking at 1/2 the antiderivative of sine of u. The antiderivative of sine of u is negative cosine, so we're going to say negative 1/2 cosine, put our x squared back in, and then plus, we're going to call it c2. So natural log of the absolute value of y plus c1 equals negative 1/2 cosine x squared plus c2. Next thing we're going to want to do, we're going to want to combine our c's. So we're going to say natural log of the absolute value of y is equal to negative 1/2 cosine x squared plus, we're going to call it c3. So we had constant 2, we were adding or subtracting constant 1 from it. So it's going to make us have some sort of constant. Again, we're going to call it constant 3, some other constant. Might be positive, might be negative. We are not sure at this point. What we will do now, though, is actually find that C3. So we're going to plug in our initial value, the point that they gave us, that 0, 1, and we are going to solve for C. So I'm going to do this one in a second color, or in a different color, so we kind of know that it's different work. So we'll say the natural log of 1 is going to be equal to negative 1/2 cosine of 0 squared plus C3. And again, we'll call this step solve for C3. And we'll even say using initial point. So the point they gave us we want to use to solve for C3. So if we look at it, natural log of 1 is 0, cosine of 0 is 1. So we're going to get C3 is going to be equal to 1/2. So plug that back in. So we're going to get natural log of the absolute value of y is equal to negative 1/2 cosine x squared plus 1/2. So we can call that the next step. We can say plug C3 in. And now we just have to solve for y. So in order to get rid of that natural log, we need to raise each side to the, or e to that side. So we're going to say absolute value of y is equal to e to the negative 1/2 cosine x squared plus 1/2 power. And something kind of interesting can happen here. I'll put it on the next slide because I'm kind of running out of room, so we'll skip it for now. I will put a little star right here because, like I said, something interesting can happen there. Our step here is just going to be solve for y. Now, we want to get y by itself. We don't want to get absolute value of y. So if we're going to get rid of the absolute value, we have to say that this is plus or minus e to the negative 1/2 cosine of x squared plus 1/2. Because if we took the absolute value of the negative, we would still get that positive value. So we have to think about positive or negative. It's not going to be both. It has to be one or the other, and we have to use our initial value to decide if we take the positive or negative. If we go back and we look at the point they gave us up here, we have a positive y value. So since we have a positive y value, we want to take the positive option. So we want to take e to the negative 1/2 cosine x squared plus 1/2 power. And that's going to be our answer. So we'll say down here, use initial value to find plus or minus. So that is a separation of variable problem. The steps are on the right, works on the left. Going back to that place with the star, e to the negative 1/2 cosine x squared plus 1/2 power. If this were a free response question, you can leave it the way we did. Everything is absolutely fine. Sometimes on multiple choice, AP is going to do something a little tricky right there, and I will show you what they do right here. So if we end up with, like we had on the other slide, the absolute value of y equals e to the negative 1/2 cosine x squared plus 1/2 power. Something that AP tends to do on their multiple choice questions is they split that up and put the constant down front. So what I'm talking about when I say that is they use their exponent rules to do that. So generally, when we have two things with the same base multiplied together, we add their exponents. In this case, we're actually going backwards. We have addition in our exponent, so we're going to pull it apart. What we can do from there is e to the 1/2 power we know is just the square root of e. So they can write it as square root of e times e to the 1/2 cosine of x squared. Now, it's not very frequent to show up like this on a multiple choice question where you have the initial value given to you. So this is more likely to show up if it's a general solution. So if we go back to this slide, this slide here, if we don't know what C3 was, so if we go back to right here, and we don't have an initial value to solve for C3, what that can turn into, looking over back on this side, instead of having natural log of the absolute value of y equals e to the negative 1/2. Oh, sorry, we don't have e at this step. I apologize. Let's get rid of that. Oop, that's not the eraser. At this point, we still just had negative 1/2 cosine x squared plus c3. This is where we're more than likely going to have to mess with our exponents. When we can't solve for that c3, we're going to end up here, where we're going to have the absolute value of y equals e to the negative 1/2 cosine x plus c3. What they're going to do more than likely on a multiple choice question is split this up. And how they're going to handle this is e is a constant. It's a number. Raised to the c3 power, that's a constant. That's a number. What they're going to do is they're going to go like this. And they're going to rewrite e to the c3 power as just some other constant. So a multiple choice question would have an answer that looks like what you have at the bottom, except we'd still need to take care of the absolute value. So that's going to do it for this video, and we will see you in the next one.